Students will be able to determine slope when given 2 points. Yesterday, you guys looked at a graph and you looked at the slope, and most of us were fairly accurate with it, but then there was that one on example 3 that I got wrong. Do you guys remember that? And I was like, wait, it kind of looks like 1 over 1, but then we realized it was like 7 over 6. So when you're determining slope, the graph way isn't probably the most accurate method. This method today is going to be your go-to if you're looking for an accurate slope. We're going to determine slope when they give us 2 different points. And remember again, this is the same thing as yesterday, and we're just going to keep going back to this because it is a new concept. The slope of a linear function is the rate of change between the dependent variable, y, and the independent variable, x. And slope is abbreviated m. Did anybody Google why? No. Slope is abbreviated with an m. I don't know why. Do you know why? Well, I do, but I wanted you guys to Google it. Remember? I have sick kids. I don't have time for that. You're glaring at me. I'm a little bit scared. I don't want to derail the lesson because this one's a big one. Slope is always usually expressed as a ratio, which means it's best to probably leave as a fraction. We did. This is identical. And in just a minute, I'm going to have you work with the partner and try to fill out this graph. If you need to look at your notes from yesterday, you can, but I want you to try to, just from memory, draw in a line that matches these. A positive slope should be increasing. A negative slope should be decreasing. A zero slope is constant. And an undefined slope is just vertical. Draw in a line, and then try to fill out the x and the y. If you need to look at your notes from yesterday, go ahead and look at it. I'll give you a minute. You can check with your partner if you're a bit stuck on a few blanks. All right, draw a line for me, or describe your line that would be increasing. Which direction does this one go, Alexis? Yeah, it's gonna just go somewhere to the right. So we're thinking little man walks left to right, he goes up. There he goes. So as x is increasing, y is increasing. Put increase and increase if you have it. Describe what decreasing would look like. Kira Bentley. Good. As x increases, y is going to go down. Y decreases. What does my line look like when it's constant, TJ?
It's just a flat line.
Yeah, it's flat. And as x is increasing, y does nothing. So anywhere along this y-axis, it's constant. X is increasing, y stays flat. stays the same. And if it's vertical, it's obviously going to be a vertical line. What did we call that yesterday? There was a word for it that I think I left us with like the last few seconds of notes. It wouldn't be zero. This is actually called undefined. And here's why. There is no left to right movement, so there cannot be a slope. There is no left to right movement. When that happens, little man, unfortunately, tries to stand on the slope. He's not very happy because he falls to a lake or a nice trampoline like place or fire. Yeah. Oh, this is a shark. There you go. So when it's undefined, here's what's actually happening. Say I have a point that's called 2, 0, and I have another point called 2, 4. If that point is 2, 0, and this is 2, 4, what happens as I move left to right? It goes 0 times. So if I did the rise over the run, it would rise from here to here, which is 4. 1, 2, 3, 1, 2, 3, 4. So the rise over the run would be 4. But what would the run be? It's 0, because I don't move left to right. If you have 4 divided by 0, have you ever tried to divide something by 0? Let's try. It's not a number. You cannot divide 4 by 0. Here's another way to look at it. Let's put 4 on the inside of a house and try to divide it. 0 goes into 4 how many times? You can't fit 0 into 4 at all. That can't happen. You can't divide 4 into 0 different sections. Could you do the opposite and split up 0 4 different sections? Yeah, you could put 0 things into 4 different sections, but you can't split up 4 things into 0 sections. It doesn't work. So if you have 0 divided by 4, that would be your constant line. Rise over run of 0 over 4 is 0. 4 divided by 0 doesn't work. It's called undefined. You can't do it. Alexis? It would probably say error or E for error. Yeah, you can try it out. They usually don't say undefined, but that's what it actually is called because mathematicians haven't found a number that works for it. It doesn't work. You can't divide by 0 is the last section, so that's why. Rise over run 4 over 0 does not work. Little man dies. Next page. Okay. Here's the main part of our aim. That first page was kind of the foundational piece. So we know that slope is positive, it's negative, constant, or undefined. When you have a table of values, we can actually find a slope in 2 ways. If they give us a graph, let's go ahead and graph it, and we only need 2 points to do that. Let's use this point and that point. So go over 2 up 5. Go over 0 up 2. I told you guys that you didn't need rulers, but I'm now regretting my decision. Just try your best to put like a line with your binder maybe. Connect those 2. You could have also used -2, -1, but we didn't have to have a 3rd point. You could if you want to. Okay, find the slope, turn and talk with your partner once you get it. Go. 2, 5, and 0, 2. Up. 3. What's our slope going to be, Tennyson? a rise of 3 and a run of 2 would work. So 3 over 2 is how I'm going to put it. Now, what if they didn't give us a graph? If they don't give you a graph, and this is the preferred method by mathematicians, you can solve it using algebra. Here's how. They actually have a slope formula that works every time you have 2 points. And the slope formula works like this. Slope is going to be a y point on your table of values minus another y point on the table of values. That's also the change in the y's. So we changed in the y's 3 different units. And then you're going to place the run as the change in the x in one of the points minus the change in the x in another one. This is your equation you're going to keep close to your math mind. Put a star next to it. This is called the slope formula. It looks like a lot of weird numbers now, so just like tuck this away. You're going to see why it actually works. Let's say I have the point 0, 2 right here. And this point I have is 2, 5. When we go from 2 to 5, 2 to 5, we actually went 3 units. So watch what I do. This is the second y value. We're going to make that y2. Here's our first y value. That's y1. You can flip it around if you want to and make this your first y value and this your y second. It doesn't really matter, but I'm going to use the y2 as the 5. Then you're going to match the x2 with the y2. So there's the coordinate pair 2, 5, x2, y2. Here's x1, y1. Now, when I plug in those numbers, watch what happens. What is the number for y2, Brady? Okay, what was the y1? It was this 2, right here. So your change in y values is 3. Does that look kind of like our slope? Okay, so far so good. Look at the x2 value. You have 2 and then 0. x2 is 2, x1 is 0, 2 minus 0 is 2. Is that the change in our x value? Yeah, you just found the slope without a graph just by using 2 points. You don't have to actually write this, but could I have used, let's just say, the last one? Can I use this point too? If it's on the line, it should work. Don't write this, but let's just test it out looking at the boards. Let's make this value y1 and that x1. 5 minus negative 1, 5 minus negative 1 over 2 minus negative 2. This is 6 over 4. Is that 3 over 2? It could simplify to 3 over 2. So this works as well. You could use any point that's in your table of values. Why did I kind of not use this one? Anyone know why I was just like, let's use the top 2? Yeah, Brady? Yeah, and there's another reason. Just something in that number made me go gross. That kind of looks ugly. What? What'd you say? Yeah, I'd simplify it and something else. It has a Brady. It has negatives. And I know I can make a blunder pretty easily if I have negatives, so I avoided this one, but you could have used it if you wanted to. Is this linear function increasing, decreasing, or constant? Increasing is going to be 1. Decreasing is a 2. Constant is a 3. Show me on your hand 1, 2, or 3. Go. Increasing, decreasing, or constant? Most of us have 1. Put your hands down. This is increasing. Cool, cool. They want to determine the rate of change of a line that contains these 2 points, 4, negative 3, and negative 3, 4. Put that on your graph in the next 30 seconds. 4, negative 3. Negative 3, 4. 4, negative 3. And find the slope. When you found the slope, get ready to turn and talk and compare your work with your partner. up from that point, count over to that point. Is it positive or is it negative? Write the slope down just right above it or below your graph. So you made 2 points, right? We're just going to do the old one. Count up for your y. 1, 2, 3, 4, 5, 6, 7, and count over for your y. Count up, count zero. We'll skip the turn talks. Most of us are still kind of at a different spot with our partner. If you have the answer for my slope, silent hand, share it out. Peyton, what'd you get? Row 3. Let's check. Why is it negative, Peyton? Great. Little man goes left to right. He's headed down. So we counted 1, 2, 3, 4, 5, 6, 7. There's your rise. And our run is what? Let's see if it's 6. 1, 2, 3, 4, 5, 6. One more. Peyton, what did I realize? Did you notice when I counted over? I stopped at 6 here. I have to go one more. So let's make it 7 over 7. I could simplify that as what number? TJ? Yeah, -1 would work. So m should equal -1. Let's test it out with the slope formula. Rewrite the slope formula up here. Slope formula is y2 minus y1. That means any y value minus any y value again. And then x2, any x value matching with the coordinate pair up here, minus any x value matching with the y coordinate up here. Let's make the y look like a y. Okay, go over and let's find x1, y1, x2, and y2. Liliana, does it matter what point I use for x1 or y1? It doesn't. You can choose any one. For now, let's just go with the first as x1 and y1. If I did x1 and y2, would that work? No, they need to match the coordinate pair. So both pairs have to either be 1 or both have to be 2. Then let's do x2 over here and y2 over here. Plug in your numbers in your formula. y2 is a 4. y1 is a -3. Why did I put -3 in parentheses? Turn and talk to your partner, 20 seconds, go. 5, 4, 3, 2, 1. Why did I put that in parentheses? Peyton, what are your ideas? It's a double negative, so it has to be positive. 4 minus a -3 has to show the minus and the negative. So this is going to eventually be +7. And x2 minus x1, fill in the numbers on the bottom for me. Go ahead, Peyton. -3. What's my x1 value? And so it's going to be -3 minus 4. Okay, so you have a 7 on the top, a -7 on the bottom. Your slope is 7 over -7. Is that the same thing as the slope? If I have one of the numbers negative, you can simplify it by pulling the negative out and putting it next to it. -7 over 7 is the same as -1. You just found your slope with a graph and with some algebra. Okay, is this increasing, decreasing, or undefined? It is decreasing. Cool. Headed number 1, you got 6 minutes of bronze work. If you need some help on setting it up, I'm going to put one up here. If you chose to do it a little different, than me, and you made these values x1, y1, it's still going to be the same. Just check your answer to see if you got it. At the top of your bronze work, I want you to write the slope formula so you have it handy. It's y2 minus y1. By the end of this unit, this is going to be ingrained in your head, and you will have it memorized. So the change in y over the change in x. Why did I put both numbers in parentheses? If you're a little bit stuck, track the board. That's the trickiest part of this first problem. Why did I do minus a negative number? Peyton? Yeah, this is the minus sign and this is the negative sign. You have to include both. So it's a minus a negative 14. It's not just minus positive 14. You need both negatives. Same for the bottom. It's a minus negative 13. You should have gotten a not sign, which is going to add them together. Oh. Did anybody check the answer? For bonds, yeah. Okay, then I might be able to simplify. Can I simplify 24 and 33?
No.
Let's try by 3. 24 divided by 3 is 8, and 33 divided by 3 is 11. So that does match their answer. Man, they started off the first one with a tough problem. Crazy. Okay, I did too if you haven't started that one yet. x1, y1, x2, y2.